Hello learners, welcome back to my channel Shraddha's Physics. In this lecture we will see the quantitative facts about the nuclear mass, nuclear radius and the charge density. So let us start with our topic atomic mass unit. The basic definition of this is the unit in which the atomic and nuclear masses are measured is called the atomic mass unit, or this is known as the unified mass unit. So let me write the unit in which atomic and nuclear masses are measured is called atomic mass unit, that is AMU. That is the atomic mass unit, AMU, or this is also known as unified mass unit or unified mass unit, and it's simply denoted as U. Okay, so the unit in which atomic and nuclear masses they are measured, that is called the atomic mass unit, that is AMU, or that is also known as the unified mass unit. And this one AMU we can represent one atomic mass unit, that is equal to 1/12 of, this is 1/12 of the mass of an 1/12 of the mass of an carbon atom, that is 6C12 atom, and this is equal to, if I will consider the Avogadro number, that is 6.023 into 10 power 23, so it will contain the total carbon atom. So if I will consider, so this will be into, for the 12 part of the carbon atom, I can write this is equal to 1/12 into, this will be 12 divided by 6.023 into 10 power 23 gram. Why? Because for the 12 gram of carbon atom, if I will write it here, for 12 gram of carbon atom, carbon means 6C12 atom, the number of atoms present, for 12 gram of carbon atom, the number of, means the total number of atom present equal to the Avogadro number. So that is present is equal to the Avogadro number, that is 6.023 into 10 power 23. So if I will calculate for the 1 gram, that is for the, if I will calculate the mass of therefore the mass of one carbon atom, that is 1,6C12, that will be equal to simply 12 divided by 6.023 into 10 power 23. So that's why we have written here you can see. So this 1 AMU equal to 1 atomic mass unit equal to 1/12 of the mass of the carbon atom. So this is 1/12 into, for 1 carbon atom the mass will be equal to 12 divided by 6.023 into 10 power 23. And if I will solve this one, so then 1 AMU will be equal to, this can be written as 1 atomic mass unit, this is equal to 1.66 into 10 power minus 24 gram, or it can be written as this 1 AMU is also equal to 1.66 into 10 power minus 27 kg. So this is the basic unit of the nuclear mass. or you may say that this is your atomic mass unit. Now we will see the energy equivalent to AMU. So to represent this, we know from the Einstein mass energy relation, the energy equivalent to mass we can write E equal to mc square. This is your Einstein mass energy relation. Einstein mass energy relation. Einstein mass energy relation. Einstein mass energy relation, that is E equal to mc square. Now for this E equal to mc square, again let me write, if I will consider the mass, if I will consider the mass is in AMU, mass, suppose M, mass equal to M, that is equal to 1 AMU. So 1 AMU, we know this is equal to 1.66 into 10 power minus 27 kg. You have to just remember all these things. 1 AMU equal to 1.66 into 10 power minus 27 kg. And also you know the speed of the light, that is C equal to 3 into 10 power 8 meter per second. The speed of the light 3 into 10 power 8 meter per second. Now from this relation we can write the energy equivalent to 1 AMU, the energy equivalent to 1 AMU, that is 1 atomic mass unit, that is 1 AMU we can write, that is equal to mc square, or simply for that we can write this is equal to, for the mass if I will put 1.66 into 10 power minus 27, so this will be into, the value of C is 3 into 10 power 8 whole square, and if I will calculate this value will be equal to 1.49 into 10 power minus 10 joules, this joule. Okay, so that is 1 AMU equal to 1.49 into 10 power minus 10 joule. And similarly, if I will convert this to the MeV, so this also can be written as 1 atomic mass unit. This can be written as 1.49 into 10 power minus 10 divided by 1.6 into 10 power minus 13. So it can be basically written as this is equal to 931.25 MeV, or this is near about we can write, or this is 1 AMU is near about 931 MeV. 931 MeV, where 1 MeV equal to, where 1 MeV equal to 1 mega electron volt, that is equal to 1.602 into 10 power minus 13 joule. That's why here you can see, to convert this joule unit to the mega electron volt, simply we are dividing this 1.6 into 10 power minus 13 joule. Okay, clear? And now similarly we can write for the mass of the electron, the energy equivalent to the mass of the electron. So now we can write the energy equivalent to mass of electron, energy equivalent to mass of electron can be written as mass of electron, that is Me, we can write Me, that is equal to, here let me write, this is 0.511 mega electron volt. This one is important. Okay, mass of the electron in energy equivalent term we can write this is equal to 0.511 MeV. And similarly for the mass of proton, energy equivalent to mass of proton, if I will denote this as MP, so that will be equal to 938.279 MeV. And similarly for the mass of neutron, the energy equivalent to mass of neutron, that is if I will denote this as Mn, so that is equal to Mn equal to 939 0.573 MeV. 0.573 MeV. So these are some basic fundamental ideas about the atomic mass unit and the energy equivalent to AMU. So here you have to remember 1 AMU equal to 1.49 into 10 power minus 10 joule, or this can be written as 1 AMU equal to 931 MeV. Just highlight this one. And the mass of electron is 0.511 MeV, and the mass of proton is 938.279 MeV, and mass of the neutron in energy equivalent we can write this is 939.573 MeV. Now let us see what is nuclear size and how we will represent this. So from the experimental result, or we can say experimentally, the volume of a nucleus, the volume of a nucleus is proportional to atomic mass proportional to the mass number. We can say that the mass number, that is A, the volume of the nucleus is proportional to the mass number. So what is this A? This A is nothing but, let me write what is this A. So if we'll consider, let us consider a nucleus. Let us consider a nucleus having A nucleons in it, nucleons means protons and neutrons in it, A nucleons in it. So for that case we can write the total volume of the nucleus, that will be proportional to the mass number A, or that is the total number of nucleons in it. So now for that case we can write 4 by 3 pi r cube, that is the volume of the nucleus, 4 by 3 pi r cube, that is proportional to A, where this r equal to, where r represents capital R, that is equal to the radius of the nucleus. This r is the radius of the nucleus. Okay. Now from this relation you can see that since 4 by 3 pi r cube is proportional to A, since 4 by 3 and pi, these are your constants, so we can write r cube is proportional to A. Or simply, if I will multiply 1 by 3 in the power, then this power will goes to this r power 3 into 1 by 3, that will be r power 1, and that is proportional to A power 1 by 3. So in that case we can write, if I will remove this proportionality symbol, I will write the proportionality constant, that is suppose r naught. So this will be r equal to r naught A power 1 by 3, where this r naught equal to, this is known as the empirical constant. This is the empirical constant, and its value will be equal to 1.2 into 10 power minus 15 meter. Okay. So this is the empirical constant, and its value will be 1.2 into 10 power minus 15 meter. So here we can say that again, let me write. Also we can say, as A is different, that is atomic mass is different for the different element, as A is different for different elements, therefore atomic nuclei of different elements elements have different sizes. Have different sizes. Different sizes. That is basically you can see that since A varies, so here we can say that R will vary. So how R will proportional? So R will be proportional to A. That is R is proportional to A as a power 1 by 3. So R equal to R naught into A power 1 by 3, where the value of this R naught, that is the empirical constant, equal to 1.2 into 10 power minus 15 meter. So this is your the most important relation, you can say R equal to R naught A power 1 by 3. So let us solve a question. The question is given, suppose obtain approximately obtain approximately the ratio of nuclear radii, it means the radius in the plural form, that is radii, nuclear radii of ferrum, that is iron, 26, 56, that is ZXA form, that is 26, ferrum 56, and 92 uranium 238. What is the approximate ratio to this nuclear radius? So here you can see for the iron, if I will consider, suppose A1, let me change the color. So suppose A1 I will consider, so this is equal to 56, that is for the iron, and here for the uranium, this A2, this is equal to 238, okay, 238. And from the relation, that is R equal to R naught power, R equal to R naught into A power 1 by 3. So here we can also represent this as R is proportional to A power 1 by 3. So if I take the ratio, that is for R1 divided by R2, since it is directly proportional to A power 1 by 3, so simply I can write this is A1 power 1 by 3 divided by A2 power 1 by 3. Okay. So here you can see that the value of A1 is given 56 and A2 is 238. So simply if I substitute this value here, so then that implies we can write R1 divided by R2, that will be equal to 56 divided by 238 whole power 1 by 3. This whole power 1 by 3. Now if I solve this, if you will solve this, then you will get a perfect ratio of that. Now you can see here, in this way you can solve this question. Now we will see the nuclear density. What is nuclear density? So basically we can say that the density of the nuclear matter, density of nuclear matter is the ratio of mass of nucleus and its volume, nucleus and its volume. Okay, so here we can write the volume of the nucleus. So the volume of the nucleus is simply, that is in mathematically we can write the volume of the nucleus, that is equal to 4 by 3 pi r cube, or this is simply mass divided by the volume. I will write it later. So in this part, if I put the value of r, that is here, let me write 4 by 3 pi into, in place of r, if I write r naught a power 1 by 3, and this is your whole cube. Okay, this is the nuclear size. From the nuclear size, we know the nuclear radius r will be equal to r naught a power 1 by 3, where a is the atomic mass, and this R naught is called the empirical constant, and this is equal to again 4 by 3 pi R naught cube into A. And also we can represent this volume of the nucleus. So before writing the density of the nucleus, let me tell you one thing. We know Z plus N, that is equal to the total atomic mass, where this Z equal to number of protons, Z equal to number of protons, and N equal to the number of neutrons, and A represent, this is the mass number. It is the mass number. Let us consider a nucleus. Suppose let us consider a nucleus. Let us consider a nucleus having a nucleus in it. Nucleus means protons and neutrons. Okay, having a nucleus in it. And if I will consider the mass of each nucleus, we know, and let the mass of each nucleon, that is equal to, suppose equal to m, and that is equal to 1.67 into 10 power minus 27 kg. This is mass of each nucleon. And also we know the mass of electron equal to mass of electron, that is equal to 9.1 into 10 power minus 31 kg. Okay. So therefore we can write the mass of total nucleus, that is therefore the mass of nucleus we can write, that is equal to the mass of each nucleon into the atomic mass, or that is simply, if I will denote this as capital M, or this is suppose Mn, maybe let me write this as Mn, or this is equal to Ma, or simply in some book it may be written as capital M. So that is equal to Ma, that is the simply the total mass of the nucleus. Okay, that is equal to Ma equal to 1.67 into 10 power minus 27 kg. Okay, kg into A. This is because you can see here the mass of each nucleon is 1.67 into 10 power minus 27 kg, and you have to multiply this A. So this into A. So from this expression we have calculated the mass of the nucleus. And now if I write the density of the nucleus, so if I write the density of the nucleus, so we can write the density of the nucleus, that is equal to mass of the nucleus divided by volume of the nucleus. So this is simply mass of the nucleus divided by the volume of the nucleus, Now if I put this value, that is this mass of the nucleus is nothing but, let me write, if I denote this density as rho, so rho can be denoted as equal to mass is your m into A divided by, for the volume we can write this will be 4 by 3 pi R naught cube into A. You can see from this relation we have calculated volume of the nucleus is 4 by 3 pi R naught cube into A. So simply here I have substituted the volume of the nucleus is this much. Now this A get cancelled. So here I can write rho equal to 3m divided by 4 pi R naught cube. So therefore we can write rho will be equal to 3m divided by 4 pi R naught cube. And now if I calculate the value of this density of the nucleus, so we can write the density is nothing but the mass, that is the total mass of the nucleus divided by the volume V, and this is equal to, you know, the mass of the nucleus here we have calculated, that is equal to the mass of each nucleon is 1.67 into 10 power minus 27 kg. So this mass of the nucleus will be equal to m into a. So this will be 1.67 into 10 power minus 27 kg into a. So if I write this here, so this will be rho equal to mass by volume, and that is equal to, this is 1.67 into 10 power minus 27 into a divided by, this will be v equal to 4 by 3 pi into, in place of r if I will put the value, 1.2 into 10 power minus 15 whole cube into a. Because you know, in place of capital M, that is, let me write it here, you know, rho equal to m by v, and also you can write this as capital M equal to small m into a, mass of each nucleon into atomic mass, divided by, this will be 4 by 3 pi r naught cube into a. So if you will cancel this a, so you will get this much. Okay. Now if you will solve this one, you will get the value of the density, that is rho will be equal to 2.29 into 10 power 17 kg per meter. So this is the nuclear density. Okay, that is 2.29 into 10 power 17 kg per meter cube. So you can see that this value is particularly, it is very less as compared to the density of the ordinary matter. That is, for example, if you will consider for the water, this value is rho equal to how much? 10 power 3 kg per meter cube. Okay. So for the water, this density is 10 power 3 kg per meter cube, and for the air this is simply 1.293 kg per meter cube. So the nucleus matter is very densely packed. Okay. So this is what the nuclear density. Just try to remember all those things. Okay. So in this lecture we have studied, that is, what is atomic mass unit. That is simply the nuclear mass unit or the atomic mass unit, and this is the 1/12 of the mass of the carbon atom, and its value is 1.66 into 10 power minus 27 kg. And if I write the energy equivalent to AMU, so this value equal to 1.49 into 10 power minus 10 joule, and that is simply 1 AMU equal to 931 MU. And similarly, you can see the energy equivalent to the mass of electron, proton and the neutron. And in the next we have seen the nuclear size, that is R equal to R naught a power 1 by 3, and the nuclear density equal to, you can see here, the density equal to 2.29 into 10 power 17 kg per meter cube. So this is all for today. If you have any doubt, can ask me in the comment section. Thank you all.